Hello, 8th grade math students. Mr. Lawrence here, and I put a video together to help you prepare for the test. So now, I don't want any excuses about you can't watch the video because you don't have earbuds, all right? I'm going to write a note on the board about that. You are to watch this video. If you need to turn the volume down, that's fine. You can go over to Mrs. Boutsiere and get some earbuds, whatever it takes. But you watch the video. It'll help you prepare for the test. And then today in class, after you finish the video, there will be the online test that will be a good practice test for you. So let's get down and do this because I'm going to do several problems for you. I'm going to try to explain them as best I can, and then you're going to go and practice them. All right, so this says a class is having a bake sale. The class earns 10 cents for each cookie sold. I just heard a slope. Did you hear that? It's always about slope. That would be 10 cents per cookie. Yeah, 10 cents per cookie. That's a slope, 10 cents. All right, draw a graph to model the situation. Now I got a question for you. Should my graph be a series of points like this? Or should it be a continuous graph? Should it be discrete, which is just points, or continuous, where you connect all the points together? Okay, hopefully you're thinking it's this one because we're not going to sell a half a cookie, a third of a cookie, a quarter of a cookie. We're only going to sell one cookie, get 10 cents. 2 cookies, 20 cents. 3 cookies, 30 cents. Okay, draw a graph to model this situation. How many cookies would the class need to sell 30 cents? Well, since I know the graph has to be discrete, a series of points, it's either got to be B or C, so I'm going to ignore A and D. Now I'm going to come here and look. Here they have the number of cookies. Looks like they're counting by ones, right? And here they have the money earned, and that's in cents. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. It looks like each mark is 4 cents, right? Okay, now it says 10 cents per cookie. Over here they have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Looks like this mark is 3 cents per cookie. Right? 3 cents per cookie. So the slope on this one, well, maybe not. Yeah, the slope on this one is, we're going to have to figure out. Okay, so this one's showing 4 cents for every line, and this one's showing 3 cents. So let's see, the slope right here. If I look at this point right here, that's at 1 cookie, and it's getting me 8 cents. How do I know it's getting me 8 cents? Because it's 2 marks up, 4, 8, 12, 16, 20, 24, right? Over here, this mark, I can't really tell. It's 1, but I can't tell what the y coordinate is. It's not 9, 3, 6, 9, because it looks like it's a hair above it. It might be 10, which would be good, because that would be 10 cents per cookie. But let's see if I can tell. So let me use a different point. Looks like I've got this one crossing at a nice intersection right here. Let me do it in green. Okay, that's 3 cookies. So 3 cookies, and they made 30 cents. 30 cents, right? So if I take 30 cents and divide by 3 cookies, don't I get 10 cents per cookie? That means this is the correct answer. All right, moving right along, the next question. The graph shows a proportional relationship between a family's distance from home, y, and the time they spent driving, x. Write an equation for the relationship shown by the graph. Well, remember, you need y equals mx plus b, where b is the y-intercept, right? We know this already. This is review. That's the y-intercept, and m is the slope. Now we can get the slope a lot of different ways. When I have a graph, my favorite way to get the slope is to do the rise over the run. Okay, well, let's get the y-intercept first of all. Let me scroll down just a hair. The y-intercept is the place where the line crosses the y-axis, right there. The y-intercept is 0. So my equation is going to be y equals mx. It would have plus 0 on the end, but it makes it more complicated, so I'm not going to bother writing plus 0. Because if I add 0 to it, nothing happens. Now let me see here. Let me see if I can count my slope. It looks like they might be counting by 52. How the heck did I get 52? Well, I went up 2 blocks to 104, so I divided 104 by 2. Yeah, 2 blocks, so it's 52. Let's see if I'm right. If I'm right, then this would be 52 more, so it'd be 156. And if I add 52 to that, I'm going to get 208. So I am right. So it's going up 52, the rise is 52, and the run is 1. My slope M, must be 52 over 1, or better yet, just 52. My equation then is simple. Y equals 52x. And what that means is I'm driving, or this family is driving at a rate of 52 miles per hour. That's exactly what this means. Okay? In 10 hours, they would have gone 520 miles. Watch. Y equals 52. How many hours? 10. 52 times 10 is 520. And see, there it is, 520 miles per hour. I know I'm correct. All right, this one here says a candle burns at a rate of 1 inch per hour. Draw a graph to model the situation. How long will the candle last? Well, the number of hours is along the x-axis, right? In all 4 cases. It always will be. Time is always your independent variable. It's along the x-axis. And then the height in inches is along the y-axis, right? Height in inches. Now, 2 of these answers are ridiculous. 2 of them are ridiculous. When you burn a candle, does it get bigger or smaller? Look at this. Candle A is getting bigger the longer you burn it. You burn it for 10 hours and it's up to 10 inches tall. But at 1 hour, it was only 1 inch tall. That's ridiculous. Over here, the same thing. Same thing is happening. Now, if you could decide whether this is discrete data, like this, or continuous data like that, candle's getting smaller, it's got to go down to the right, it has a negative slope, you could answer this question without doing any work. So let's see, when I burn a candle, every hour, does the candle start off like this, and then 1 hour later, it's, 59 minutes later, it's this length, but then all of a sudden, poof, it's a little bit shorter. Is that how it works? Or does it gradually get smaller? It's here and then goes down and then burns more and then burns more and burns more. I hope you can see that this is continuous data. The choice has to be B. C does not make sense because the candle will change heights at 1 hour 15 minutes, 1 hour 16 minutes, 1 hour 17 minutes, 1 hour 17 and a half minutes. All right, moving right along. It says the amount of money Y Pizzeria K makes by selling pizzas can be modeled by the equation Y equals 11x. So if they sell 1 pizza, they make $11. 2 pizzas is 22. 3 pizzas is 33. I'm just doing 11 times the number of pizzas. The relationship of the amount of money Pizzeria W makes is shown in the following graph. So let's see. This is Pizzeria Y. This is Pizzeria W. Let's see if we can find the slope. Well, there's the y-intercept. What are they counting by? Well, 38 divided by 2 is 19. They're counting by 19. And if we rise 19 and then we run 1, our slope is 19 over 1, or just 19. So Pizzeria W's equation would be y equals 19x. We don't have anything added on to the end because the y-intercept is 0. Pizzeria W is the more expensive one, and it's making more money per pizza. Hopefully it's a better quality pizza because that's a big price difference, right? Okay. This one here says the graph shows the number of calories burned running. How many calories do you burn per minute? Tell you what, I'm not going to answer this one. You are. Pause the video and see if you can figure out how many calories you burn per minute. Here's some music to help you think. Do, 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 do. Just kidding. Okay, so hopefully you've done this problem. If you haven't, you need to do it. Here comes my solution. Well, I want to see how much 1 is. Well, 1 is half of this, which would be 8 2/10, right? And so my rise is going to be 8 2/10 calories per minute, because this would be 1 minute, right? So they're burning 8 2/10 calories per minute. That's my slope. It's all about the slope. It's crazy. It's all over the place. And that answers the question, 8 2/10 calories per minute. All right, doing great. Okay, you would need to hire a DJ for a party. The DJ charges an initial fee plus an hourly rate. If you don't know the initial fee, that's going to be your y-intercept. Yeah, did you hear that? That's your y-intercept. That's your y-intercept. Marissa, did you hear that? It's a y-intercept plus an hourly rate. An hourly rate is going to be the slope. Why? Because it's going to be so much per hour. $6 per hour, $12 per hour, $25 per hour. Okay, that's going to be your slope. All right, the graph shows the relationship between the cost and time. What is the hourly rate? Well, we need the slope. So let's see here. Here's a point right here. And let me see if I can find another intersection. Oh, there's one. Okay, so what's the rise? How much am I rising? Looks like they're counting by 50s, right? So how much did I rise? 50, 100, 150. So my rise number is 150. How did I get that? I counted up 3, and each block is 50. 50, 100, 150. Now the run is 2 hours. Okay, 2 hours. So the rate is $150 per 2 hours. The problem is they don't ask per 2 hours. They ask for an hourly rate, which means for 1 hour. Well, if I just divide 150 by 2, I get $75 per hour. Bam! I'm a genius. This is too easy. Ladies and gentlemen, you can do this. This stuff is simple. All right. Let's move right along. Moving right along. Thank you. All right. The graph the equation shown below. What is the y-intercept of the graph of the equation? I want you to go ahead and pause this. Make a graph in your notes. Got graph paper? Awesome. You need rulers. You know where they are. Go ahead and graph it. All right. So here comes my solution. You should have already tried it by now. First, I need the y-intercept, which is -3, right? Okay. And then I'll need the slope. I don't see a number in front of x. Well, how many x's are there? Just 1. There's a 1 in front of the x. And if I want the 1 as a fraction, it'll be 1 over 1. So I plot my y-intercept. I begin with it at -3. Hold on, I got to scroll a little bit. There we go. And then I rise 1, run 1. So I'm going to rise 1, run 1. All right. Do a couple more. I'm going to rise 1, run 1. And I don't think I can grab that one. I'm going to rise 1, run 1. And my graph, my line, is going to look like this. And of course, I need it to extend forever in the other direction. And I need to put an arrowhead on it. All right. There we go. Okay, we're doing great here. We only have a few more of these, and I'm going to let you go and try them on your own. Okay. The line models Maria's savings account. She started with $10 in her account. If you don't realize it, they just told you the y-intercept. Yep, that's the y-intercept. That's B. She saves $2 each day. Oh my gosh, what the heck is that? That's a slope. That's a slope. Write an equation for the line in slope-intercept form. Slope-intercept form is y equals mx plus b. So my equation should be y equals 2x plus 10. Yeah, 2x plus 10. That's it. There's nothing to this problem. The y-intercept is 10. You rise 2, you run 1. If you look, that's 1 day. Yep, number of days, 1. So the rise is 2, the run is 1, and you have y equals 2x plus 10. All right. This one says, Morgan, Alexa, and Adrian are working on a project. They want to know who types the fastest so the person can type the report. Okay, well, it says right here that y equals 38x is Morgan's words per minute. I don't know if you realize this. That means 38 is the slope. That means for Morgan, she does 38 words per 1 minute words. per minute. It's all about the slope. Okay? Now Alexa does 76 words in 2 minutes. So let me change colors here. Alexa will be in green. 76 words in 2 minutes. Well, if I divide that by 2, both by 2, I'm going to get 38 over 1. She's at 38 words per minute as well. So her slope is 38 words per minute, just like Morgan's. So they're typing at the same rate. Okay, now, let me get a color I don't normally use. There we go. All right, let's look at the graph for Adrian. We'll see what they're counting by. Looks like they're counting by 38. How did I know that? I did 76 divided by 2. So the rise is 38, the run is 1. Guess what her slope is? 38 words per minute. All 3 people type at the same exact rate. All 3 type at 38 words per minute. They all type the same rate. Their slopes are all the same. Okay, I think that's it for the problems I want to do. Let me just double check. Yeah, that's it, ladies and gentlemen. That's it for the video. So now, with the remainder of class, we're not to be throwing paper balls around the room. We're not to be distracting each other. You've got a practice test assigned to you. It's on digits. Go ahead and get it done. It's helping you get ready for this test. I'm getting so excited because light bulbs are starting to go on for a lot of you. You're starting to understand this concept. And when you take the test on Tuesday, you're going to be so proud of yourself. Make sure you do your best. All right, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody.